This is problems 21 through 23 on the practice midterm 2. We're into the multiple choice part, but there will be some work involved which we will be doing on scratch paper. And by the way, we're going to probably be using scantrons from now on as well. So we'll be filling it in on the scantron for the second part of the test, the comprehensive part. And now, the first problem, number 21, the oxidation state of nitrogen in ammonium perchlorate is A plus 4, B minus 4, C minus 3, D plus 3, E plus 7. Well, this is the simple application of the rules for assigning oxidation states. And so let's look at the molecule itself. Is the ammonium ion. So we separate the ammonium perchlorate as a salt. We'll take the ammonium ion separately, and we can solve for the oxidation state of nitrogen. Now, nitrogen is not in the early part of the rules, and the rules are in descending order of priority. It's at the end of rule number 6. So it's given the lowest priority is group number 5, 5A. They're given the lowest priority. That'd be nitrogen. So all other things have precedent over nitrogen. So we'll have to use the hydrogen to give us a guide. And so it turns out that hydrogen is covered by a rule, and it is the rule number 5. And there is hydrogen, if it's combined with a non-metal, then it's going to be given a +1 oxidation state. And if it's combined with a metal, it's going to be the -1 oxidation state. This is consistent with, again, what we've seen on the periodic table. Hydrogen appears above group 7 in the nonmetals, and that is because when it combines with a metal, it acts like a nonmetal. It forms anions. It's in the -1 oxidation state, and group 7 forms -1 anions. And it also occurs above group 1A, which is the metals, and that is because when it combines with a non-metal, it's going to form a cation, or it's going to be in the +1 oxidation state. So that's the origin of that rule with hydrogen. So hydrogen is going to here combine with a non-metal, so that means that it is in a +1 oxidation state. And so I have that +1 times 4 plus X. And now rule number 3 in our rules for assigning oxidation states state that the sum of the oxidation states has to add up to 0 if it's a neutral molecule, or the charge on the ion if it's some sort of molecular ion. And in this case, the charge on the ion is +1. And so +1 times 4 is +4, plus X equals +1, so I subtract 4 from both sides, and X is equal to -3. And so this would be option C, which you will fill in on your scantron. Okay? And now, with the same problem in problem 22, is the oxidation state of chlorine, this time, in the ammonium perchlorate. And then you have the same exact options that were present in problem 21. A is +4, B is -4, C is -3, D is +3, and E is +7. So now we'll do the same thing we did before. I'll take the perchlorate ion, and I will look through the rules and to assign the oxidation state. Well, I don't have a hard fast rule on oxygen until I get to rule number 6. which is where they, which has precedent over what. And oxygen is given a higher precedent than many of the things. It's given only a lower precedent. The only thing that's lower than is fluorine. Fluorine is given the highest precedent. Oxygen is next, and then oxygen is given a oxidation state of -2 in that case. And then the chlorine is given a lower priority. Group 7A, other than fluorine, is given a lower priority than oxygen. So that means I will use oxygen in the -2 oxidation state and use rule number 3, which is that they must add up to the charge on the ion, which is going to be -1, to assign the oxidation state to chlorine. You can do this with practice visually, but let's work it out just for fun anyway. So I have -2 times 4 plus x has to be equal to -1 in this case. Well, -2 times 4 is -8, so I add 8 to both sides, and that gives me, therefore, x equals plus 7. And that is option number E, which you will fill out on your Scantron. And just for laughs, I want you to put a mark on the test as well, so we have a hard copy backup. So fill in the bubble on the test, fill in the bubble on the Scantron. And that way, we've got some hard copy backup in case there was some sort of screw up on one or the other of them. And now, we're given a problem that is going to require some calculation. And this is just a simple matter of this is practice with the factor label method. Light with a wavelength of with lambda equal to 500 nanometers, and that's supposed to be an M here, corresponds to A, 2 times 10 to the -4th reciprocal centimeters or wave numbers, B, 5 times 10 to the -6th wave numbers, C, 2 times 10 to the 4th reciprocal centimeters, and I'm using reciprocal centimeters and wave numbers here interchangeably because they're the same thing. All the notation is cm to the -1, so we call it reciprocal centimeters. It also corresponds to wave numbers because it represents the number of these waves that will travel and be contained in 1 centimeter of length. So that's why it's called wave numbers. Okay. And so, and then D was 5 times 10 to the -7th wave numbers, and E was 96,485 wave numbers, or reciprocal centimeters. So now we're going to have to do a little bit of calculation because this is a wavelength, and this is a length as well. So reciprocal centimeters is going to be, we're just going to have to convert between the units. And now, so I'm going to want to have, I'll have 500, I'll denote that as 5 times 10 squared nanometers. Okay. And I'm going to want to take it, or convert this to some reciprocal length. But, so I'll put this in brackets, see if I can write this out in one quick expression. This, I start out with nanometers. I want to go to centimeters. I can either go through meters or go directly to centimeters. How many nanometers are there in a centimeter? Well, there's 10 to the 9th nanometers in a meter, and a centimeter is 10 to the -2 meters. So I can just move the decimal point over. So it would be, there is 10 to the, 1 centimeter is going to be 10 to the 7th nanometers. And so I can do that conversion and then close the brackets and take this to -1 and take the reciprocal. At this point, we can easily just deal with the characteristic and the mantissa, and it'll be revealing. It'll put us where we need to be. Well, let's go ahead and this is going to be equal to, the characteristic is going to be, no, first let's carry this out. Okay. The nanometers cancel. I have 10 to the squared over 10 to the 7th, so it's going to be 5 times 10 squared over 10 to the 7th. And this, I'm going to take the reciprocal off. And this is going to be, yeah, I'll just do this, -1, and it's going to be reciprocal centimeters. So now I've got everything that I have to take reciprocal of. Now, 10 squared divided by 10 to the 7th is what? What do I do? Well, I subtract. So 2 minus 7. So that's going to be equal to 5 times 10 to the -5 to the -1. Okay, well that's going to be, and that's going to be centimeters again. And that, it turns out to be, now I can use, let's just pick the 5 and pull it out. 5 to the -1 times 10 to the -5th times 10 to the -1. What do I do here? Well, in this case, this comes back to knowing when to add, when to multiply. -5 times -1 is times 10 to the 5th centimeters, reciprocal centimeters. And so now I got to figure out what the reciprocal of 5 is. Well, that's pretty easy. 5 goes into 1.00, 0.2 times. So it's going to be equal, this is going to be equal to, although we can already answer the question by looking at, well, no, I guess we can answer the question. That means that the answer here is equal to 0.2 times 10 to the 5th reciprocal centimeters. And now I move this decimal point 1 to the right, and that's equal to 2.0 times 10 to the, if I move it to the right, I subtract 1. This becomes 1 lower, times 10 to the 4th centimeters. Although I pretty much knew it was going to be a 2. So I had to be either this one or that one, and I know it went back to the -4th, so we could have answered the question a minute ago without going there. But I think going this distance was good. So this is a straightforward conversion, and that's all that is, and that is option number C. So on your Scantron and on your test, fill in the bubble.